Okay, welcome back everyone. Today we're going to look at modeling functions with patterns. Now there's three particular patterns we're going to look at in this section. Linear, quadratic, and exponential. Okay, now certain functions do have very predictable characteristics. Now linear is something you guys have seen before, y equals mx plus b. Okay, the linear leads to line, so the graph of this thing is a line. Okay. The quadratic is what we've talked about these last few topics in these videos. Quadratic is ax squared plus bx plus c. Remember, the graph of that looks like a parabola. And for an exponential function, this may be new for some of you, but it's y equals ab to the x, where your x is the exponent. Okay, so that x is actually up on the b as an exponent. And the graph looks like the one pictured here, where it rises like this. There's also a possibility where the graph may decrease and look like that. But it's a very similar graph, and it's just a matter of actually reflecting that thing. Okay, so those are the three graphs that we're going to look at. Now, what you're going to be asked to do in this section is to initially just plot some points. So graph the ordered pair and then classify. So based on what this set of points looks like, you're going to be able to hopefully pick off out of those three we looked at which graph that is. Okay, so we graph these points just like you would any other point. Okay, so we'll start with example A. So the first point is -2, -3. So starting at my origin, I go left 2, down 3, and I've got my point there. The next point is -1, -1, so I end up with there. Now 2 points is not going to tell you enough. You need to keep going. Okay, 0, 1 looks like it'd be right there. 1, 3 is right 1, up 3, and you've got that point there. And what you'll notice is if I were to connect these points, it should create a straight line, which it does, which means this set of points is linear. So that's kind of the initial first step of this section, is to just graph these things, see if you can identify what they fall into. Alright, the second one. Now this has got some decimals to it. Just graph as accurately as you possibly can. So for this first one, you got -1.25. Now 0.25 is 1/4, so I go left 1, and then I'm going to go up about 1/4, which kind of puts me about right there on my graph. The next one is the 0.01, so that's just taking me up 1. The next one is over 1 and up 4, which would put you right here. And then following that, you've got 2, 16. Now 16 is going to be way off my graph, but if you kind of look up there, it's going to be kind of like that. Now, without knowing a whole lot more, we are kind of left to speculate. Well, if we just take these points and connect it that direction, we have to assume that it goes off in both directions the same way it did previously. And if you look it over at the exponential graph, which is up there on the right, that's kind of what this looks like. So we're going to assume that it would continue on this direction, and it would continue upwards in that direction, and this would be an exponential function. Okay, so by graphing points, you can get an idea of what these might look like, and then just label them as such. Now, what we can also do is look for patterns, and patterns are going to tell us exactly which model these fits. And we're going to look at the y values. Now, the big thing to watch for is your x values must be increasing by 1. Yes, you want your x values to be increasing by 1 for this to actually work out the way it should. And all of your assignments that you're going to have, whether it be the test, the quiz, or just your homework assignment, that will be the case. So if the difference in the y values are equal, then it is a linear function, meaning if you subtract your y's and they're all the same, it's going to be linear. Okay, the second possibility. If the second difference of y values are equal, but the first aren't, it is quadratic. And I'll show you an example of this so you can see what I mean. But in this first one where it's linear, this is the first difference. Okay, down here it's the second difference, meaning you have to subtract twice. Now the third possibility, we saw linear, we saw quadratic. The third one is exponential. And if the ratios of the y values are equal, but it's not 1, then it's exponential. And ratios refer to a fraction or division. Okay, so we're going to look at these things as a fraction or using division to see how this works. Alright, so keeping those in mind, Let's try a couple of these. So here we go. Use the pattern to classify the points. Now remember what I said about the x values. The x values must be increasing by 1, and in this case they are. Okay, so since they're increasing by 1, we're okay. Everything's just fine. So now you look at your y's. Well, from -8 to -3, what have you done? Well, if we're thinking in terms of difference, we're going to think subtraction. Okay, so the difference between these would be 5. We added 5 to get from -8 to -3. Now we look again from -3 to +2. Well, if I were to subtract -2 minus a -3, I would get 5. So I added 5. Okay, from 2 to 7, you would add 5. From 7 to 12, you would add 5. And since that's the case, remember we look up here now, if the differences of the y values are equal, it is linear. So that set of points represents a linear function. Alright, second possibility. Again, our y's are pretty standard, so we're okay with, or sorry, our x's are going up by 1, so we're okay with that. Our next one, we look at the y values. So from here to here, I subtracted 4. From here to here, I subtracted 2. Well, there's a problem there. Okay? From here to here, I subtracted 1. Those are all becoming different. Now, that's the first difference. So let's look at the second difference. From -4 to -2, I added 2. From -2 to -1, I added 1. It doesn't fall into my patterns. So it's not linear because the red is not the same. It's not quadratic because the green is not the same. So that leaves exponential. Well, exponential is fractional. So I'm going to take my y's and I'm going to set them up as a ratio, meaning a fraction. Okay, so I'm going to do 4 divided by 8. Well, 4 divided by 8 is 1/2. Okay, so that works. So now I look at 4 and 2. So I set up with 2 divided by 4, which is 1/2. That works. Okay, so now I've got that. Those are both the same. So now I look at this 2 and this 1. So I go 1 over 2, which is 1/2. And at this point you should start seeing that that is the fraction that we want. And that's the ratio. Okay, so since this has a common ratio of 1/2 in all of these cases, okay, so again it was 4 over 8, 2 over 4, 1 over 2. I could do 1/2 over 1. All of those are equal to 1/2, so this is exponential. And that's how you determine that one. Okay, let's look at the next. Quadratics. Here's how quadratics work. Okay, we're going to test all of our y values to see what's happening. Okay, so let's start with subtraction. So from 3 to 7, I subtract 4. Okay, from 7 to -9, I subtract 2. From -9 to -9, I subtract 0. From -9 to 7, I'm actually adding 2. That's the first difference. Since they're different, we know it's not linear. But now let's look at the second difference. From -4 to 2, I'm adding 2. From -2 to 0, I'm adding 2. From 0 to 2, I'm adding 2. And since the second difference is the same, that means this thing is a quadratic, and that's how we classify it. So that's how you're going to determine these. Okay? Try to see if the first difference is the same. If it is, it's linear. Okay? If the first difference is not the same, the second difference is not the same, try the ratios. If it is, which this example was, that's exponential. And then finally, try the first difference. It's not, so it's not linear. Try the second difference. That worked. That makes it quadratic. So that's how you're going to determine which of these three categories it falls into, just by looking at the points. Now finally, we want to find the model that fits. And remember, when we talk about models, we're talking equations. So we want to know what's the equation that works for all of these. Okay, here's what we're going to do. We're going to start with this one. And now remember, we already found this. Okay, this was linear because the difference in each of those is 5. We added 5 every time. Okay? So what we want to be able to do is take this and determine how can we actually solve this? What kind of model can we make based on this here? Well, what we have is a bunch of x values and y values. Okay, so our x is here, our y is here. Our x is here, y is here. X is here, y is here. And we can go through using this process to solve this out. Now y equals mx plus b. We all know that from the linear function. What ends up happening is this value helps us out. Okay, that value right there is your m. So we take that, that's our m, which is a slope, if you remember that. And we pick any one of these other points as an x and y. So let's say we choose this 1 and 7. Now where there's a y in this equation, I'm going to substitute in the 7. So it becomes 7 equals m. Well, we decided m was 5. So it becomes 5. Okay, x goes back and we use this point again. So the x was the 1. And what we don't know is the b. So we put our b right there. And now just go through and solve this. So 5 times 1 is 5. You subtract 5 from both sides. After that multiplication, you get b equals 2. Well, we know what b is. We know what m is. So back to our model, y equals mx, so 5x plus b, which is 2. That's the linear equation in which those points would work. And you could plug in and test every one of those points, and they would all work within that function. So that is the correct function. Alright, so now let's check with this one. Now this is a repeat of what we did before, so this is exponential. And remember that we said our ratio was 1/2. Well, up at the beginning, we had y equals ab to the x. Now your ratio is your b value. And then we treat this the same way we did all the other ones. We could say that this is an x, this is a y, and we use those two there to substitute in for x and y over on that side. Okay, so y, which is 2, equals a. We don't know a. Okay, the b value is 1/2, and the x in this case is 1. Okay, and those 2 and 1 come from that point right there. And now solve it. So 2 equals, well, 1/2 to the first power is just 1/2. So you have 1/2 a. Solve this by multiplying both sides by 2. You get a equals 4. Those two will cancel, and then 2 times 2 is 4. So we know a is 4. Well, we know a, we know b from right there, and we put it in our model. So y equals a, which is 4, times b, which is 1/2, to the x power, and there is your function. Okay, so it's choosing any one of these, and I could have chosen any of these points to substitute into that equation, and it would have worked just the same way. Alright, finally, what we've got here is the quadratics. Okay, now the quadratics, the function was y equals a x squared plus bx plus c. Okay, so we've got to figure out how this helps us out. Well, there's a couple of different ways you can go through this. If you remember when we graphed these things, we said that c was our y-intercept. It was 0, c. That point right there looks pretty familiar. Okay, that might be our y-intercept, so 0, c. Okay, so I've got y equals. I'm going to pick just another one, so we'll choose this one. Okay, so there's my y. So I've got -7 equals a x squared. Well, we know what x is. X is 1. Okay, for this point, remember I said we're choosing that point. So it's 1 squared plus b, we're not sure what b is, times 1 plus c. Well, we know what c is. Remember, c was this right here, which is -9. So I go through, I can solve this, add 9 to both sides. You get 2 equals 1 squared is 1, or a. B squared is 1, which is b. And you've got that so far. And remember, this is one of the approaches that we could use. Now the other way, we need to find another point. So go through and we just pick another point. So let's say we choose -3 and -3. That's another x and y. We go through this same process again right over here. So taking this, plug it back into that formula. So y was -3 equals a times x. X was -3. B is -3. And C is -9. Okay, so what you've got, I'm going to add 9 to both sides. It gives you 6. -3 squared is 9, so that's 9a. And then here you've got a -3b. And setting those up, you've got 6 equals 9a minus 3b. Now there's a bunch of different ways to go through it from here. If you've been introduced to substitution, you could use substitution. If you've been introduced to elimination, you can try elimination. Find a method that works for you and solve that out. Okay? One method that may be beneficial is to try substitution. Okay, so we'll go b is equal to 2 minus a. So we substitute this in right to here, and we've got 6 equals 9a minus 3 times 2 minus a. Scoot this down a little. So 6 equals 9a minus 6 plus 3a. Okay, so solving this out, those two go there. They combine together. That gives you a 12a. I'm going to scoot this over here, erase this part. So I've got 6 equals 12a minus 6. Add 6 to both sides. Okay, so those cancel. You end up with 12 equals 12a. So a equals 1. Now what we're going to do is we're going to take this, substitute it back into there, and you end up with 2 equals 1 plus b. Okay, subtract your 1 from both sides, and you end up with b equals 1. Well, we know a is 1, we know b is 1, we know c is -9 from right up here. So the final answer here would be y equals ax squared. Well, a was 1, so it's just x squared, plus bx, well, that's 1, plus c, c was -9. There's your function, and you're done. Okay, so the quadratic definitely takes a little extra work, but in the long run, there's a couple different ways. The system of equations, if you've seen it, is probably the most beneficial way. You just need to make sure you can set it up correctly. Alright, finally, here is our final problem. So we've got cars depreciate in value according to this table. Okay, depreciate means goes down in value. So after so many years, these cars have lost some kind of value. So we want to determine the model used. Okay, so determine the model used. Well, a couple ways. You can graph these things, see if it works out. You can find the difference, see if that works. Okay, and those are some of those methods that we talked about up above. Now the key to this is looking here. See how these all have different cent amounts? What that's going to lead me to believe is that subtraction isn't going to work. Okay, so I'm going to try using division first. So if I take this number divided by this number, I'm going to get 0.86. Okay, now in your calculators you can go through this. It's a pretty quick process. But if you then take this number divided by this number, that's 0.86. And so this is showing that I've got a ratio here. So this 11,767.04 divided by $13,682.60 gives you 0.86. And then the last one also gives you 0.86. So we're at least seeing that this may be where we need to go. Now the nice thing about these is if they give you a 0, okay, so in this example I've got a 0. what ends up happening is that's your initial value. Your initial value is A. If you remember back, and we scroll back up, kind of follow along here, here's my initial value. Okay, I have a 0. Well, when we solve this out, remember we said that our A was 4. Well, look what that is right next to it. Okay, so anytime that you have a 0, that is your A value. The 0.86 in this case is your B. So the model, remember we said that it's a ratio, so the model is exponential. The equation, y equals a b to the x, well, we know this. Y equals A. A is $18,500 times B, which is 0.86 to the x. There's your model. Now the last part of this problem says find the value after 7 years. What that means is your x value has become 7. Okay, so we're going to take our function right here and we're going to substitute in 7. So 18,500 times 0.86 to the 7th power. And from there, that turns into just a calculator problem. So you go 18,500 times 0.86 raised to the 7th power. Hopefully you guys know how to do that in your calculators. And after 7 years, this gives me a value of $6,436.66. And there you go. So in those 7 years, your car has depreciated nearly a little over $12,000. Alright, so that's dealing with models. Hopefully that made some sense. I know a couple of these are a little bit tricky. If you have further questions, contact me online. I would be happy to help you, sit down and walk you through some of these problems and make sure you guys got some sense of them. Alright, good luck. Let me know if you have any questions.